Hello, welcome. This is my shop. This is my project. I want to share my experiments with the my attempts at replicating a Bedini motor, and get some feedback on it. See what other people think. Where can I make improvements, mistakes I may possibly have, and what it's going to take to get this to a larger scale. This is my work area at home. The Bedini motor here, it's got a dual coil. I'll show you more of that later. Batteries, currently I've got 6 12-volt batteries under there. As I collect more, people throw them away, add them. Currently I'm running it off of a AC power supply. It's 20-volt power supply. Here's a oscilloscope here. That is just actually a computer, but it's a DSO. And so we follow right now. It's just showing the across the emitter collector on the trigger transistor. Okay, get a closer look at what I've got going here. Just the main parts. Again, this is a power transformer here. It's AC. It's about 19.5 volts that it's putting out DC. The motor itself, the rotor, which is 12 neodymium magnets in here. This coil here is 4 windings, each of about I think 23 gauge. They all came off of old television yokes. Anyway, each length's about 150, or no, and this one's 120 feet. This one back here is only 3 windings, and it is I don't know, maybe 70, 80 feet each, I think. That was when I rolled a long time ago. I don't remember. They're not the same. Bearing is off of a drum from a VCR. Meters here. Obviously, you're not going to see the radiant spikes on a multimeter like this. This here is just for checking battery, which is over here, all the battery terminals coming up. This here is to measure my amp draw coming from the power supply, which right now it looks it's about 200 milliamps. The pot here, it's 1K pot. Circuit, and kind of got a mixed match of transistors. These here are actually 2 SD880s, both of those, and then there's a third one here, which is there's a crossed part number, an NTE 130. This is my probe right here. Ground to common ground, which is coming from power supply, and actually triggering it off of the collector for the first transistor, which is this. This is my drive coil. I'm using a single winding for the trigger, and then the other 2 I've got hooked in parallel, going into the drive transistor. I'm triggering all windings are being triggered from the same trigger winding off of this one here. And then on this coil, I just separated it, so I put 2 windings in parallel. So there's two windings on this one, 2 windings on the next one, and again it's being triggered from the trigger back here. And I've got these set as close as possible. If I move it any closer, it starts shaking and making a bunch of racket. It doesn't seem to improve the performance. So right about where I've got it now, which is about an eighth, maybe a tad more than an eighth of an inch gap between the core and the magnets, seems to be where it's working the best. Okay, so here is the output from the oscilloscope, and what we're seeing, this is connected to the batteries right now for charging. So first of all, the scale of it is vertically it's 10 volts per division, so that's showing between 30 and 40 there. I don't know if I'm saying his name correctly or not, but Monsieur Bonheur, who's got a great tutorial on PESWiki, made the comment that this part right here, the top to this, the H here, I guess you'd call it, the width of that is the actual energy that's being lost or drawn to power this. And so the smaller this can be made, the more efficient the motor, is my understanding from what he's saying. And I've tried a number of different transistors in an attempt to make the switching faster, to narrow that. However, I don't know, I've got buckets and buckets of all kinds of transistors, but apparently not the exact right ones for this. Anyway, my horizontal scale is 1 millisecond here, so we're seeing a total period there of about 2.5 milliseconds, about 390 hertz frequency. Let me disconnect the battery here and show you what the spikes look like. Okay, everything's the same except for I just disconnected the charging batteries, which I don't typically do just because it's pushing a lot of all that energy is then going through the neons and the transistors, and it's just hard on the circuit, I think. Anyway, when I disconnect it, some interesting things happen. Without that load, frequency is dropped. So instead of running previously at about 390 hertz, it's dropped down to about 340 hertz. And the voltage looks, well, it's about 170 volt total here, peak to peak, and which, you know, it's none to write home about, but I've different configurations. I've had it around 400, a little over 400, I guess, and that's without connecting coils in series, which obviously would send it a lot higher. I've heard some discussion, you know, or read some discussion both ways on if it's best to run your coils in parallel or series, and I've seen debate both ways. So I'm interested in input on that also. If what's the recommended? What's the difference? Do we want basically, are we looking for more of a radiant current going in, or are we looking more for a high voltage radiant spike going in? Which is going to be more beneficial? Some things that I've got here, just quickly sketched out schematic for what I've got here, and I'll post this so we can look at it a little closer. Also, this is just for the last couple days, but been keeping track of all of the you know, voltages, checking it at different times, checking what the charge is, and so forth. Any thoughts on anything here, how I can improve it? I'm excited to hear. Thank you.